Fourth and final team, this is CleanNG.
Hi, my name is Matt Villarreal. I'm the CEO of CleanNG and inventor of the MagmaCell fuel storage system. I have with me a great team, including Michael Tate, Chief Operations Officer, Jacob Crawley, Chief Marketing Officer, and Alex Diamond, Chief Technology Officer. We are the co-founders of CleanNG, an innovator of advanced performance products for natural gas vehicles. We're an Oklahoma LLC, established in October 1st of 2010. We're located in Stillwater, Oklahoma. Our mission is to revolutionize onboard fuel storage systems for natural gas vehicles. Our idea came from the Pickens Plant Initiative and a spinoff of the OK State Racing Team's Compressed Natural Gas Initiative, where we created America's first compressed natural gas Formula SAE racer. Now, let's think about something for a second here. $4 a gallon gas is yet to hit Oklahoma, but it's only a matter of time before we feel the pain at the pump, like people in California and New York already do. Now, if you think this is hurting your wallet, think of a fleet owner. Let's say one who's operating 60 medium-duty vehicles. This fleet is going to use about 90,000 gallons of fuel per year. At the average gas price on March 2nd, of $3.08, this fleet owner is going to spend over $270,000 on fuel for 1 year. At the same time, compressed natural gas is only $1.93 per gallon equivalent. If the fleet owner converted, he would save over $100,000 per year on fuel costs. That's the cost of buying 3 new vehicles every year. Now, you may be thinking to yourself, I've heard a lot about natural gas vehicles lately. T-Boone Pickens, CNBC, MSNBC, they're all talking about it. But if they're so great, why aren't we all driving? Well, there's 2 main problems with the adoption of natural gas vehicles. One, the fuel storage systems lack range, which is mainly due to the weight, size, and capacity of the system. And 2, there's a lack of infrastructure, which is in its early growth stage and is expected to grow significantly in the next 5 years. Our solution is the MagmaCell fuel storage system. It uses advanced materials and a scalable design to create value for customers in 2 ways. 1, we can increase fuel storage capacity by 50%. And 2, we can increase your vehicle's fuel economy by as much as 4%.
The global market for natural gas vehicles currently is at $3.1 billion and expected to nearly double in the next 5 years. Now, the U.S. market for natural gas fuel storage tanks is currently at $374 million. And by 2016, this number is expected to exceed $726 million. This data is based off a growth rate that is expected to continue at an average of 18% per year. Now, CleanNG's market can be broken down into about 3 segments based off of penetration. Your first segment are your retrofitters. These make up 60% of the market, equaling 224,000 tanks. Second are your fleet operators. Retrofitters. Second, fleet operators. These are, for example, small, medium, and large companies. Also, private, government, and commercial companies. They make up 30% of the market, equaling 112,000 units. Lastly, number 3 are your OEMs, or original equipment manufacturers. These make up the remaining 10% of the market and equal 37,400 units. Now, trends affecting this market are increases in gasoline fuel prices, as well as increases in natural gas fuel consumption. Also, government incentives, such as the Natural Gas Act and over 950 more in Oklahoma and Texas alone. Also, green initiatives to lower the carbon footprint will affect and increase CleanNG's market size. Now, the buying cycle for the retrofitter can be broken down into 5 steps. In step 1, the technical director recognizes a need, say for fuel storage. Step 2 involves a conversion engineer gathering information for the requirements needed for the conversion. Step 3 involves the technical director coming back in evaluating the options and alternatives gathered in Step 2. Step 4 is the purchase decision. This decision is based off of cost, quality, and availability of fuel system components. The last step is the post-purchase evaluation. This will be performed by the quality control manager. Typical customers of CleanNG include over 40 different retrofitters across the United States. Top prospective customers include OEMs such as BEF Technologies and Natural Drive, conversion companies such as Tulsa Gas Technologies and Clean Vehicle Solutions, and lastly, fleet operators such as AT&T and Fine Airport Parking in Tulsa, who we are currently in communications with to develop our beta prototype. Now, there are currently 2 different vehicle type setups for medium-sized vehicles on the market. You have your 3 and your 4 tank setups. These affect the range the vehicle can travel, as well as the weight of the vehicle. The higher the weight, the lower the fuel economy. Now, a typical BAF vehicle with a 3 tank system and a 20 gas gallon equivalent system will produce 300 miles for a total range of the vehicle, increasing the weight by 415 pounds. Now, if CleanNG has used the same 3 tank system, we will produce 30 gas gallon equivalents, increasing the range by 150 miles, bringing the total range to 450 miles compared to the 300 mile range of the BAF vehicle. Now, on the other hand, if CleanNG is to use the 20 gas gallon equivalent system, we will produce 30 gas gallon equivalents, decreasing weight by 215 pounds, while increasing fuel economy by 4%, also eliminating one of those tanks. CleanNG's marketing strategy is going to consist of directly contacting customers. Trade magazines are constantly looking for new companies and products to feature, and CleanNG is going to leverage these opportunities to receive media recognition. Also, we're going to attract preference and attract early adopters by incorporating them into beta testing. As you can see here, a typical selling cycle is 4 months, with an average sales size of $60,000. At this point, the sales team will engage in personal selling. The first step will require the sales associate to contact the technical director, who is the key decision maker, emphasizing on building a relationship and creating product preference for the MagnaCell. During those 4 months, the sales team at key decision points will send out marketing material covering product and pricing information on the MagnaCell. Lastly, a comprehensive feedback process will ensure that we receive and they will be able to implement this with the quality control manager. Lastly, all this will be backed directly by social media and marketing.
CleanNG is in the prototype development stage, and we're excited to announce that this will be completed by the end of May. With help from outside engineering consultants, we have validated our design through computer-aided design modeling and material testing of our product. Upon completion of our prototype, CleanNG will move into phase 2 of design and development, which includes additional prototyping, testing, and meeting government regulations by December of this year. Other major milestones include January, where we commence beta testing, followed by full operations in March. We project our first sales to be made in May of 2012. Now, as you can see behind me, there's a breakdown of our design and development costs. The majority of these costs come from labor, equipment use, and testing. Also included in these funds are the cost to protect our intellectual property. These funds total $350,000 and will bring the MagnaCell to commercialization. In order to sustain a competitive advantage in the marketplace over new entrants and incumbents, CleanNG will invest heavily in its intellectual property protection. We filed a provisional patent application for our MagnaCell fuel storage system, which has a possible of 3 inventions. A utility patent covers the application of our materials and the materials themselves. A method patent covers our manufacturing process for the system. And finally, a design patent covers the unique feel and look of the MagnaCell. We currently have office space in the Cowboy Idea Hatchery, which is a business incubator hosted by the Riata Center for Entrepreneurship here at OSU. We plan on moving our facilities to the Meridian Technology Center in year 1, where we will obtain 800 square feet for our main office, research and development lab, and warehousing. Now, out of the space, we will conduct inventory management, new product development, sales procurements, and marketing. And by year 5, we plan on expanding to an additional 1,500 square feet. Our operations strategy consists of outsourcing and manufacturing. And we have a working relationship with Luxor Gas Cylinders in Riverside, California, and we're evaluating their capabilities to meet our manufacturing needs. Once we have obtained funding and design development is complete, we will initiate our operations cycle, beginning with order processing. We will notify the supplier to send materials to the manufacturer, and for the manufacturer to start producing once those materials are received. Our manufacturer will produce, assemble, and package the Magna cell, and perform quality checkpoints at 3 different stages, as you can see in our diagram. Once these orders are complete, they'll be sent to us at our headquarters in Stillwater, where we will hold inventory. When orders come in from the sales team, they will be shipped from inventory to the customer, and customer service will follow up to ensure accuracy and delivery. Once the sales cycle is set, the supplier and the manufacturer will communicate back and forth to meet production needs, while CleanNG communicates with the manufacturer and, most importantly, our customers. The management team, which is comprised of the co-founders, has bootstrapped all milestones to date and is committed to making CleanNG a high-quality provider of natural gas vehicle products. The team has been researching alternative fuels and natural gas vehicles for more than 3 years now. The team brings characteristics of passion, experience, and knowledge in the fields of entrepreneurship, marketing, engineering, science, and technology. And we firmly believe that with our resources, connections, and strategy, we will commercialize the Magna cell. To assist us with this is additional team members such as Suhir Bandla, a PhD candidate in composites here at OSU. He will be our materials engineer. Paul Graves is a resin engineer that has more than 25 years of experience working with different applications for resins. And McLean Anderson is a filament winding company manufacturer who will provide initial lab space for CleanNG to develop its prototype. Upon capital infusion, CleanNG will also add a chief financial officer, full sales team, and operations staff. We've also established a strong board of advisors consisting of successful entrepreneurs and industry veterans who bring special expertise in the fields of financials, operations, marketing, and engineering, totaling more than 75 years of experience. In addition to these board of advisors, as participation in the Cowboy Idea Hatchery, we have access to outside consultants and mentors who bring bring insight, connections, and resources that help CleanNG develop its technology, operations, and our strategies.
CleanNG is a high-margin, high-growth potential company with low fixed costs due to our outsourced manufacturing. We expect to incur about 55% variable costs, and we will utilize multiple revenue drivers due to our scalable tank design, which can be distributed to a variety of customers across multiple segments. We expect to reach break-even in month 33 at approximately 1,671 units. As sales commence in May, we project revenues growing from $206,000 to over $16.2 million in year 5. Our sales units, they'll grow from 96 units to a projected 8,420 units in year 5. As we progress, our margins will grow from 16% to 45%. We expect to reach profitability in year 3 at $893,000. We currently project investment in 3 rounds. Currently, we're seeking seed investment of $350,000 in exchange for 26% membership equity in our LLC. Additionally, we plan to raise Series A funding in year 2 of $500,000 and Series B funding in year 4 at $650,000. Our projected valuation at exit is around $39 million using a 6x price earnings multiplier. Founders and investors can expect an exit, a liquidity event in year 5 via merger, acquisition, or direct public offering. At this time, seed stage investors can expect over 20 times return on their investment, or approximately $7.2 million. In summary, CleanNG is an innovator of advanced performance products for natural gas vehicles. We're an Oklahoma LLC established in 2010, and we have committed founders who have foregone traditional career paths to pursue this great opportunity and invested our own personal funds in the venture. We've completed initial product validation and are seeking a seed investment of $350,000 to bring the MagnaCell to market. Thank you for your time. We'd now like to entertain any questions.
Why hasn't someone developed a tank like this before?
Well, currently most of the tanks are set at 3,600 psi, and as the pressure increases, the price of the tank increases dramatically. Our material has a great cost advantage. It's over 40% cheaper than what's currently out there on the market, so we can provide more storage capacity at the same price as the competitors are currently offering.
And did you have a couple of patents applied for?
We have applied for a provisional. It's mainly just a placeholder, but when we complete our prototypes, we will file for a non-provisional patent.
Do you think it'll be enough to hold off the competition?
I think it will. There's only a limited number of suppliers for the components that we're using, and if we can give them a significant use for their product, then we're going to be able to establish an exclusive partnership with them.
Nobody else is currently using our material for this purpose. It's kind of undiscovered, so we'll be the first to really put it in this application.
Can you comment on what impact this will have on collisions? I mean, how does it stand up with the 16-wheeler where it's a cab using yours versus the current one on the market?
Well, in order to bring this product to market, we have to meet stringent tests. Right here. We have to meet all these tests and all these standards. You can't sell this to anyone unless you have tried this out, tested it, and proven by third-party validation that it will not explode when it's shot with a high-powered rifle, exploded with dynamite, dropped from 10 stories. I mean, this thing is solid, and it is not gonna rupture.
The pressure that's holding 3,600, 4,000 psi is more than any collision with another vehicle will encounter. So it is actually designed to hold the pressure that any collision would impact.
Also, in our initial product validation, this material had a tensile strength or a pressure rating of 10,000 psi. We're only stepping it up a little bit, so we have that increased safety factor when we actually commercialize it.
How comfortable do you feel with the rate of conversion of existing vehicles to CNG?
Well,
But if they don't convert a certain number every year, how does that affect your projections?
well, if the U.S. is currently one of the slowest converters of natural gas vehicles. There's still a great opportunity, but if the U.S. doesn't continue to increase conversion rates, we'll move into South America, Southeast Asia. Actually, those countries have the largest opportunity, and they're growing at rates of 96% year over year, high rates of conversion. So we'll switch our strategy to focus on international markets.
I must add, though, I've been working with Tulsa Gas Technologies over the last semester, one of the companies I've been in contact with, learning about the conversion process, even helping out, and they are swamped. I mean, they're needing to expand right now. They build filling stations and they do retrofitting, and they have too much work that they can handle, and it's just taking off like it never has before.
Also, another company we were in contact with, we were actually in contact with one of their investors, Clean Vehicle Solutions. They're expecting to convert 5,000 vehicles next year. And what they told us is they can't keep enough tanks in supply to do all these conversions. So there's a huge need for suppliers of these tanks.
What does the conversion cost? What does the conversion cost?
Currently, the conversion from, it depends what retrofitter you go to, but typical conversion, depending on the size of the tank, anywhere from $6,000 to $10,000 after installation costs. And right now, I think for individual retrofit vehicles, that the labor is pretty high because of it not being done on a very large scale yet. But about that price that I just said, at least half of it's labor. So when that scales up, the cost to actually retrofit, obviously.
Also, to add to that, our example with the 60 vehicles being converted and the 90,000, they would see a return on their investment after 3 years, including the conversion and the cost of fuel.
That was for a fleet.
That was for a fleet of 60 medium-duty vehicles.
What about, is this really cost effective for just an individual vehicle owner?
Not currently. Probably 90% of the vehicles that are converted are fleets. And yeah, there's a lot of fleets. Chesapeake actually just converted over 7,000 of their vehicles to compressed natural gas, and other companies like Verizon and AT&T, they're the main ones who are converted.
What about, Pickens' plan is more for the big 18-wheelers.
Right.
Now, can they use these tanks in the 18-wheelers?
Oh yeah, absolutely.
Yeah,
They see the most benefit from them, actually.
Yeah, and really the more heavy duty the vehicle, the bigger benefit you're getting. You see hybrid technology, electric, all these other things coming out. They're great for small vehicles. Once you get past the size of, say, an F-150, Chevy Silverado, current storage energy density of hybrid system, electric systems, you simply can't store enough energy to get enough range when you get to the larger duty vehicles.
Question. Page 8 of your plan on buyer behavior, you say customers are likely to resist the buying process because of previously established relationships, but after recognizing the Magna sells superior benefits of reduced size and weight, they'll purchase or switch to the superior product. My thought was, when I read that, I wish human beings were that rational. They aren't. So who are these previously established relationships that could potentially be an impediment in your selling process that you have to sell through?
Well, currently the competitors are other manufacturers of natural gas tanks, such as Lincoln Composites or Experion.
So are you going to have to displace them in an account? Or is the market expanding to where you're competing for accounts for which there are no incumbent relationships?
We will compete with the currently established retrofitters, but as this market grows, there's going to be a ton of new retrofitters in the market, and we do plan to target them before anyone else does. So I don't see any problem with us getting in there with those new guys, but there will be a resistance from the established.
What is the rate of formation of new retrofitters in the United States?
I don't currently have a statistic for that, but the expected growth.
Right, is it a growth industry, or
Oh yeah, this is a high growth industry.
retrofitters?
Yeah, like you said, there's currently 40 on the market right now within the United States. This number is growing. But as we project, our market research projects that this will shift slowly to fleet operators and the OEM. But right now, our current market is the retrofitters, which is increasing.
Okay. With respect to your intellectual property, is it the particular material that the IP relates to, or is it the use of that material in this application of a tank?
The material is the foundation of our intellectual property, but also the manufacturing process of that material, since it hasn't been used for this application before, is one of the patents, the process patent, and also it has a unique look and feel, the finished product. So that is also another component that we're pursuing.
Is this an OSU IP?
No,
Where did the IP
this is
come from?
completely ours. To follow up with what Alex said, once we manufacture this, the material components that we use are going to form a new material. So we are using current materials that are on the market, but once we process them, they are a new material.
So who is the legal owner of the IP today?
CleanNG is the legal owner.
Okay,
We created the
established
IP,
it.
yes.
Are you going to run into issues on the regulators because your gas is going to be under a lot higher pressure? Is that an issue?
We do expect to see some resistance in that, but over the past 30 years, they have upped the fuel pressure regulations at least 3 times, and it's more related to the factor of safety associated with them. So they don't want to put something on somebody's vehicle that's not safe enough to hold that pressure. So it's not as much related to the gas as it is to the safety of the tank.
But are there regulators now that fit on your tanks that then feed the fuel into the carburetor that can handle these higher PSIs?
Right, there are. They're mostly used for hydrogen, which is stored at higher pressures.
And we talked to Steve Spalding, who's the director of OSU Transit here, obviously at OSU, and he said that there's basically a compressor in between that reduces the amount of pressure before it goes into the engine. So it doesn't actually go in at the storage pressure, it's reduced along the way. So basically it's the same application.
When you look at these conversions, you have you factored in the sensors and other things that are there, and the electronics that go in an automobile that needs to be converted, and
Yes.
and
This
you
is
factored in your $10,000 and all that?
Right, we're not actually doing the conversions. We are producing tanks, and only tanks at this point. We do have a plan to move into vehicle conversions when we have established our company and gained a reputation, but currently we're not doing vehicle conversions. We are only manufacturing tanks.
And as far as the conversion process goes, we are just doing the tank aspect. But being personally involved with the conversion process, it is very straightforward. You use the only modifications you do are just to the fuel system. You hook up a different piggyback computer to it to reprogram the fuel, and it runs just as well as gasoline and just as seamlessly. So it is not a major overhaul to the conversion.
I see quite a few of them in India. For $300, they take cooking gas tanks, stick them in the car, but they don't have all these electronics, and they run fairly well. So you need to be factoring those things when you are trying to go into the South Asian market.
Definitely. Currently, in order to not void your warranty, you have to have all these certified parts. You have to have the right regulators. You have to have the right fuel map and the right computer system. So it would be much easier to move into the markets like India or South America, where they're not regulated by the EPA. But this is the biggest growth opportunity because it hasn't got on here yet.
So the advantage of the technology is that it can store CNG at a much higher pressure rate.
Right.
But it's, so across the country, we're seeing somewhat the development of refilling stations.
Right.
Are they capable, are they being built to refill tanks at this pressure rating, or are they building those dispensary devices to only be able to fill to the lower pressure rating?
Well, Tulsa Gas Technologies that I've been working with, they do retrofitting, and they actually build the stations. The core of their business actually is, they make the most money off of building the stations because they're such a high demand. And they do have stations that will go up to, I know, at least 7,200 PSI, where the standard right now is 3,600.
So my question then is, if that's the case, if in order to fully exploit the technology that the cell represents, I have to have a station that can actually operate at that level, then at what pressure level are the stations being in progress being built today, wherever they may be in this region of the country? At what pressure rating can they fill a tank?
Right. Currently, they're operating at 3,600 psi. When they're doing this compression, it's done in stages. So this will require them to add maybe one additional stage to the current system to bring it up to 5,800 psi.
So if I roll up in my vehicle and I have one of your tanks and I want to fill mine at 7,200,
Right.
they need to, the station, the filling station, needs to have something over and above, perhaps, what they have today to be able to let me take advantage of my tanks.
Right. That's one of the great things about the lack of infrastructure is if we create preference for our tank, then the standard infrastructure will be 5,800 psi. There's not much, there is some infrastructure, but not significant infrastructure. So we can still take advantage of this opportunity with many new fueling stations being planned.
So if I roll up to the station that was just opened up here in Stillwater, can I fill, using that station, your tank to the maximum rating?
Right, you probably won't be able to fill it completely to the maximum. You can overfill. Typically they do that with the tanks that are on the market because as you fill the pressure, it heats up the tank. So once it condenses, you get a lower pressure. So they have the capability to overfill the tank, but not up to 5,800 psi. But
So you're hoping that you can be a first mover in the marketplace. Otherwise, potential value of your cell, again, we hold this high PSI rating, can't really be exploited. You've got that, is that correct?
right, you won't see as high benefits if the preference doesn't change. But if it doesn't change, then natural gas vehicles aren't going to pick up because they're not practical for anyone to use other than
At a lower pressure rate.
right.
You showed your margin increasing from year 1 to 5 by quite a bit. Why?
That's our gross margin, just because we believe we'll be more efficient as we grow and we'll be able to take out some components of our operating costs. So it's
So you're saying you're going to hold your fixed costs more, but your manufacturing costs, are they going to change?
right. We'll also be buying more materials. That's currently around 80% of the cost of manufacturing a tank, composite tank. So as we buy more materials, we'll achieve economies of scale and the cost per tank will go down. And the materials cost that we're
You're
having
pretty
to
sure it's
buy.
going to go down that much?
Well, it's not all associated with the materials. It's other things
So
regarding our manufacturing process.
Yes, for committee.
Mr. Ward, have a question?
How much of the conversion cost is covered by tax credits?
I believe it's about 1/3 of the cost. It really depends if you're installing 6 tanks on a bus, it's probably going to be a lot more of the conversion cost. But for an average vehicle, light duty F-150, it's going to be about 2,000 of the 6,000 converted.
Also, there's a
Yes,
Natural Gas Act that's in Congress right now. And I think, if I'm not mistaken, part of that is for infrastructure and vehicle conversions, where if it passes, 100% of infrastructure will be subsidized and 80% of the conversion cost.
And it has big support from both sides right now as far as politically speaking. So it's most likely going to be passed.
That's a T-Boo's push right there.
Yeah.
So is your premise that CNG is not viable unless tank pressure ratings go up? Is that generally accepted in the industry?
Well,
Or are you having to evangelize that concept?
it's not practical for individual users. So it's not practical if I want to go take my Jeep and go do it. But once you hit 7 vehicles in your fleet, it becomes cost effective. And the payoff is actually worth the conversion. So upwards of that.
But you're betting on whether, on pressure rating in the tank.
Right.
So you said that CNG for large operators is not cost effective unless they use a more highly pressurized tank.
Sorry, maybe I misspoke. It's mainly for private users. It's really cost effective for large fleets because they're using a lot of fuel, like 90,000 gallons of fuel for 60 vehicles.
Regardless of whether it's your tank or anyone else's.
Right.
Thank you. Thank you, team. Well, those were 4 great presentations. I know the judges are not going to have an easy time sorting this out. They're going to do that right now. Again, though, would everybody please join me in thanking the judges? And we will announce the winner of the $25,000 first prize, the $10,000 second prize, the $5,000 third prize at the entrepreneurship banquet tonight. Thank you, everybody, for joining us.